We're going to do the launch today. Today we have, everybody gets to finally meet the illustrious Ramil, our CTO and partner at our partner company, Consider It Done. We're so stoked to have you here. We're thrilled. We have been doing a ton of promotion and everyone's met me, but now they're going to get to meet you. I'll give the introduction because, happy to do that. So Ramil and I have worked together since 2016, and Consider It Done as well. So Ramil had early work in Ethermint, which was like the artist formerly known as Ethermint. Ethermint was later rebranded to Evmos. Ramil's background is as a full stack developer, so he's also a Solidity developer. He's familiar with Rust. So he's like our resident genius that we keep around and make sure that he's well taken care of. So it's an honor to have you here, sir.
Thank you for introduction. Nice to be here.
Great. So why don't you share your screen and we'll go through all of this totally awesome work that we've done, and we can get a look into the open source work that we're about to do.
Thank you. Let me do that. Do you see my screen?
Let me pull it in. All right.
So I'm going to talk about the Landslide project. So what is it and what we're doing here? So Nathan, would you like me to start that, or you have some intro word about that?
Yeah. So generally, if people are watching this or listening to it, we're the McDonald's version is we're connecting IBC to Avalanche. So anything that can run on IBC right now, it's just mostly Cosmos, but that will change over time. So that will include like Near and Polkadot, and as those chains communicate over IBC, those apps can deploy outposts to Landslide. So that means that Osmosis can run an outpost. Any particular Cosmos chain, anything on Juno can run an outpost and take advantage of liquidity in different IBC connected zones. And so what we're going to talk about today is basically taking the Cosmos, the CosmWasm stack, throwing out Tendermint and replacing it with Avalanche. So Ramil's going to go through all that today.
Thank you. So first, let me do a couple of words about the Landslide itself. So what is Landslide? It's a Tendermint fork to run on Avalanche subnet. It allows to run in Tendermint IBCI application on a subnet. And also it allows to run the Cosmos SDK application on subnet. So Cosmos SDK application, it's IBCI application as well, but with some additional modules. So we'll talk about that as well. So why do we need that? First, it allows to bring the Cosmos ecosystem, Cosmos application to Avalanche. Also, it's decreased finality, and it allows to connect the Avalanche to IBC-enabled chains. So Landslide contains two components. It's LandslideCore and Landslide SDK. LandslideCore it's a fork of the Tendermint. It's like Tendermint and the Cosmos SDK, right? So LandslideCore, it's fork of Tendermint. Landslide SDK, it's fork of the Cosmos SDK. So our LandslideCore, it's so how we implemented that. So there is a Tendermint, right? And Tendermint contains a lot of components like mempool, stateDB, state, P2P component, block executor, blockDB, HTTP server consensus, a lot of things included on the Tendermint. And Tendermint node, it's like initialize and running all this component together. And the key component of the Tendermint, it's actually P2P and BFT component, consensus component, right? So it's proof of stake consensus algorithm used on Tendermint, but on Landslide, on the Avalanche subnetwork, we don't need to care about the consensus because Avalanche itself takes responsibility of that. So to be able to run the Tendermint application on Avalanche, on Avalanche subnetwork, we developed a LandslideCore VM, and we took the components from Tendermint itself and initialized that on the virtual machine level, like mempool, StateDB. We removed the peer-to-peer because we don't need that, block executor, block store, some bus event. And we initialize that and we run that in the Avalanche virtual machine context. So it's we our virtual machine accept transaction like in the Tendermint format, store that on the database on Tendermint format as well, wrapped by the Avalanche DB manager. But the consensus component is not used from the Tendermint. So for consensus, we rely on the Avalanche as regular subnet. So let me show the source code. So here's the repo, LandslideCore, and we open sourced it today. But I would like to mention what it's still in active development. So it's not ready for production yet. So we are going to run it on testnet in the next couple of weeks. But you are welcome to run it on the subnet, and maybe you will find some bugs. So please do that. So I would like to show. So we forked, as I said, the Tendermint, and we trying to keep the folder structure the same as on Tendermint. So it allows us to easily upgrade to the new version. We're trying to not modify the Tendermint code, right, to keep it as is as possible, and all our logic implemented on the virtual machine. So right here we have implemented the virtual machine interface, what's required by Avalanche, and here we initialize database, block store, as I said, the set state. Also, one more interesting thing, what we this virtual machine accept the let me show that. Accept the IBCI application. So it's possible to pass here any IBCI application what follows this interface from the Tendermint, and we create a connection to this application, and it works together with our virtual machine. So we initialize that virtual machine, and also we support.
Sorry,
the key
just to interrupt, that
yeah.
ABCI application, what is going to be ported in from there?
So currently we have in our test we use in Tendermint there are two applications. It's a counter application and the key value application. What exists on the
But it's a placeholder for what other type of apps?
For Cosmos SDK. So
Bingo.
Cosmos SDK is IBCI application, but with more complex structure.
Right.
Yeah, but for now, in our test here, we use counter application and KV store application, just a standard Tendermint application, and we run them on our virtual machine. So we can see here what we initialize, we create a new counter application, and we pass it to our virtual machine. Another thing what we support on the our Landslide.
Sorry,
Yeah.
before you move on, because that's totally awesome. That's basically where any Cosmos SDK DApp can pull in, and excuse me, push out information.
It's I will talk about that. It's not 100% correct because there is some notes what I need to mention about the compatibility with the Cosmos SDK, but in general, you're right.
Great.
Yeah, also the interesting thing what we support the same interface, the same endpoints for Tendermint. So Tendermint has gRPC and JSON RPC server, right, to be able to query transaction, to broadcast transaction, and we support all of them in our virtual machine. So we support all these interfaces from Tendermint, and it's possible to query, for example, to do some broadcast transaction and to our endpoint and virtual machine. It will be accepted by our LandslideCore and passed to the IBCI application. So
Understood.
we're working to achieve the 100% coverage on test cases for this compatibility. So we're working, it's still in the progress, but in general, we support all these things in LandslideCore. It's very important because it's the key component, it's the key feature of our Landslide, and it allows us to then to support the Cosmos SDK application. Let's talk about that.
Great.
So for Cosmos SDK is a IBCI application what has a different components, right? Already developed component modules. What we do, we fork with the Cosmos SDK, and we name it Landslide SDK. And the idea is to let me step back a bit. So LandslideCore support it allows to run the IBCI application, and it contains the modules what are required for it without peer-to-peer and consensus. In Landslide SDK, we port the modules from the Cosmos SDK, but not all of them because it's not 100% compatible. For example, Cosmos has some slashing mechanism, and also to rely on some data on the block header information about the commits, what we don't have in our Landslide. So what we're doing,
Wait, I just want to pause there. So slashing, for the Cosmos maximalist, how do we ensure Byzantine fault tolerance without slashing?
So we fully rely on the security and consensus from the Avalanche. So the security of the subnet on Avalanche is achieved by it's inherited from the security of the mainnet, right? Because to be able to be a validator on the subnet, this validator needs to be also running on the mainnet. And it has a nice security model and the proof of stake consensus model. So, and our subnet is fully inherited that model.
Bingo. So we don't need to be concerned about long range attacks. We don't need to be concerned about slashing and uptime requirements yes, but we don't natively slash.
Mm-hmm. Yeah, correct. Yeah, so uptime requirements is still need to fill because the Avalanche has some requirement for validator. Yeah, but there is no selection there. And so we had to throw out some component, some modules from the Cosmos SDK, and bit rewrite the other modules. So, and the idea of the Landslide SDK, so this project is currently in progress as well. So we are going to open source that in the next couple of weeks because currently it's active development phase. Currently we're working on the WASM component, but let me talk about that a bit later. So the idea what Landslide SDK, it's like a repository with the components, already built-in components, what allow developer to create some Landslide application, for example, DeFi application, compose modules what's required for them, for example, band component, IBC component, CosmWasm component, and then they will be able to, maybe they would like to run some custom logic, and then they will be able to compile and run this application as a subnet out of box. So if they follow this, just use this Landslide SDK as dependency and use the modules from the Landslide SDK, they will be able to create application and customize that, right, and run on the Avalanche subnetwork. That's the general idea of the Landslide SDK.
That was great. Thank you.
Any questions about that, or we will go through questions?
That's a good question. Actually, let me find out from Twitter
Mhm.
if we have any. If there are other people in Twitter who have questions, please throw up a hand, and I can take some questions on Twitter or YouTube. But if not, we're gonna keep going. I think we're good.
Okay, I would like to talk about what our what we're doing currently and what is our plan. So we currently do work on two things. We work on the IBC Light Client for the Avalanche. So to be able to run the IBC, to connect. So the general idea is to connect the Avalanche to the IBC compatible chains like Cosmos, Osmosis, Juno. Avalanche support the cross-chain messaging between the subnets, and we leverage that feature and security and encryption to add support for IBC. Meantime, we also work to add support for WASM, for CosmWasm, and it will allow us to actually execute any smart contract written on the CosmWasm and Rust and compiled as WebAssembly on our Landslide application, right? So it gives the unlimited option to the developers to bring the Cosmos application to the Avalanche. DeFi application, liquid staking, and other. Right. So, and one more interesting thing, what we also working on the IBC support on the subnet AVM. So it will be fork of the subnet AVM with IBC on the precompiled level implementation, and it's will allow users to actually do some cross-chain transaction from Solidity through IBC, not only to other subnet on Avalanche, but also to other Cosmos network, and in
Yeah,
future to Near
that's
and
insane.
Polkadot.
That's so crazy. Every time I hear that, it's great, man. People are stoked.
Yeah, so it's our goal, and we currently working on these two things, and we are going to run on the testnet, I think, the next couple of weeks in public testnet. And so please try to run that, build some application, run them, and give feedback.
Yeah, we're gonna announce soon after this is out how our program's going to work for incentivization, but it'll look similar to what Axelar is doing. So we'll be in testnet for the next couple months. But yeah, just like Ramil said.
And here's the link to the GitHub repo. So it's open sourced, as I said. So it's right here. So yeah, it could contain some bugs, some issue. So if you find that, please create an issue. So and we will follow the standard open source development lifecycle. And yeah, so preparing for open source the Landslide SDK and run on testnet in the next couple of weeks or months.
Amazing. Yes, we did it. We did. Just a bit of a background. Actually, I got a question here from Twitter. Hold on just a second. Let me see if I can get him up here. All right, Sheldon, what's your question?
Hey, thanks for having me up. So, I really appreciate y'all's work. I have tried to attract some AVAX degens to y'all's work because I believe it's really important for AVAX, and y'all are doing excellent stuff. Congrats on the testnet. I'll definitely be interested to play around. I'm certainly not sharp enough.
Lost you there, Sheldon. I'll try again. Sorry.
Me personally, I've been drawing people's attention to data chains work on IBC-RS for Ethereum and some other different integrations. Now that Cosmos Eco is sort of putting on that song and dance, or being a little bit more markety in trying to draw attention to data chains work now that it's a little bit further along, can you explain how or what the relationship is between the sort of like seemingly separate effort to get IBC functional on Ethereum native? Because I recognize that P-chain is very different, but at the same time, I'd like to understand what you guys see in that environment, because I think if there's a direct liquid relationship between the chain's execution and ETH native and other CosmWasm chains, I think that makes AVAX much more appealing as an ecosystem to me. I'm not a particular fan of EVM. I'm terribly annoyed by JS, but I think that that makes a lot of sense. It's also a much more disruptive narrative than people tend to allude to. Like, I mean, the way that you're describing it, I think, is that it's based on CosmWasm. Is that correct?
Yeah. So your question is basically, how are we going to integrate with IBC on ETH?
The IBC implementation.
Or IBC in general?
Sorry, I can be kind of imprecise with questions sometimes. Let me try to ask that a little bit more neatly. There are some other efforts to bring IBC to certain EVM environments. Can you tell us, besides Evmos, what you see in that in the next 6 months or so?
Where else is IBC expanding to? What other chains? Is that right? Just making sure I get it right.
You guys doing some cross-platform stuff? I wasn't sure you were actually on here. It seems like you're
yeah.
Kind of broadcasting in two places.
Oh, sorry. Is that better? Is that better? Yeah. Sorry. So you're saying IBC? Talk about IBC expanding.
Well, in the context of EVM native platforms that aren't Evmos, because the Evmos relationship is pretty direct and linear, but like AVAX chains having their own IBC relationship directly with ETH is a very interesting concept to consider. I'm not sure it's possible.
Sure.
Maybe let me try to answer that, how I understand this question. So let me try to share my screen.
Yeah. Sorry. Let me just plug back in. Yeah. Sorry, we're doing cross-platform. Oh, sorry. There you go. Now we're back. Okay, go ahead, Ramil.
Yeah. Can I share my screen, please?
Yeah, sure.
So yeah, Here's some high-level diagram how IBC connection will work. So IBC require like two chains, right, connected through the layer. And on each chain, we need to have the light client for opposite chain. On our Avalanche subnet on the Landslide, we will run in case we are connecting to Cosmos chain, we will have running the Tendermint light client. And on the Cosmos chain, what will be connected to our Avalanche subnet, we need to have Avalanche light client, what we're currently working on. And it allows to connect the Avalanche subnet and the Cosmos chain, right? On Avalanche subnet, currently what we presenting is Landslide. But also, apart from that, we are working on the subnet EVM support for that as well. So what does it mean? It means what subnet EVM, it's EVM compatible chain, right? What any user can run. And on our fork of subnet EVM with IBC, they will be able to run actually the same thing. It's we will provide the precompiles on the solidity level from the solidity to virtual machine, and any chain like Cosmos chain will be able to connect with that through relay to the our subnet and pass the data, pass transaction. And also the user will be able from the our EVM subnet pass data to the Cosmos chain. Using the same security mechanism what we use on Avalanche Light Client and Tendermint Light Client, but it will be natively through Solidity. So user don't need to worry about the security, etc. So just call the function, and then we will take care of the IBC integration. So does it answer question?
Correct?
Yeah, so his question is it
not unique, but like, Hermes implementation or something?
as long as it's communicating through the IBC relayer, it should be secure.
Well, I'm not poking you on security. I'm just asking because at Octopus Network we've been working on a solution for trying to integrate multiple IBC Light clients, and the idea that we would just use that to communicate directly with Cosmos alone is kind of insufficient. So I was trying to scope what that would look like to bring you guys into the fore, because what we have at the moment is a sort of media converter type relayer, something that understands Cosmos events and substrate extrinsics, because we're doing some similar work in parallel on different subjects. It's hopefully going into prod either late this quarter or early next quarter. But I was just trying to understand what the requirements would be to communicate with that relayer.
So yeah.
I don't mean to bother you.
No problem. Hold on, I'll plug back in.
Yeah, so for relayer, it's probably relayer will need to know how to communicate with the EVM chain right through the EVM calls. So because currently it's works for Cosmos only networks, and this communication channel, I think integration channel between relayer and the chains will be for EVM chain could be a bit different, but in general, the protocol itself will be compatible so we will follow the IBC protocol itself about the method, security, all these things. But it will be like transport probably will be EVM function call. So relayer needs to support the Cosmos communication and the EVM, but the security will be the same.
But not this intimately. I think I'm going to ask you some more questions offline. I don't mean to take over the spaces. I'm sorry. Please, can you drop a link to where you're presenting diagrams under the Twitter spaces? I'd really love to follow along.
Yeah, absolutely. You can on YouTube. Totally. I'll do my best to share it. All right, Ramil, do you want to continue?
I think that's it about my presentation.
Okay.
So, um, any other questions?
Um, let's see. My, you know, I think future topics to discuss is like, the more experimental mesh security, bring that in, what that's going to look like. That's sort of happening, like interchain security is happening on Cosmos, and what that may look like when we bring it into Landslide. And then we just got off a call with the movement subnet, and they're bringing the move VM and language into the Avalanche subnet, and they want to communicate to other like Solana and to the those move based VMs. So that's sort of the, I don't know, future.
Mm-hmm. So I think, yeah, for that we can leverage the IBC model, right? So what
Exactly.
we already have, and because Avalanche has cross-chain communication between the subnets, right? So we can easily do the communication channel between our Landslide subnetwork and the Move subnetwork, right? And on our side we have IBC, so we can be something like a proxy for them to pass data between their network to the external world through IBC.
Great. No, I think that's great. I think that's it. We can keep it nice and short. Like, we're gonna open source the repo, and we're gonna kick off testnet. So thank you so much for your time. If there are no other questions, Sheldon, you're welcome to. I see you talking on the space. Why don't you just shoot me a DM, and we'll jump on a call sometime soon. Yeah, this has been great, Ramil. Thank you so much for your time. We're thrilled to
Thank
have you,
you.
and thrilled to see your work.
Thank you. Have a